Flack math! Give me some math and I'll give you some flack. Flack math!
Okay, lesson 43. I do enjoy this one too. And I know that's a big surprise, but this is going to be good. We are going to solve systems of linear equalities. And when you do it with graphing, you get to color a lot, and it's really fun. Did I say equalities? Inequalities. Okay. Solve systems of linear inequalities. Okay. So remember, a system of equations was just like x's and y's, and you can solve by substitution, elimination, or graphing. So it's just the same thing, but inequalities are not equal signs. They're less than or equal to, less than, greater than or equal to signs. So the way we graph those, we already talked about graphing linear inequalities, where you graph the line and then you shade on top of it or below it. Remember that? So system of linear inequalities is the same thing as system of equations, where you're trying to find the x and y that work in both equations, where they intersect. But with linear inequalities, you're going to figure out where the shading overlaps. And that's your solution to the system of inequalities. Okay? So we're just going to jump right into that. Okay? So example 1. So really, it says determine, I'm going to just change the question, but I'm going to just write 2 inequalities here. Y is less than 3, and then x plus 2y is less than or equal to 4. Okay? So the first step is to graph these 2 inequalities. Okay? So what do we need before we can graph? Graph. We need a graph. That's right. What else? Can we graph these right now? Can we graph these as they are in this form right now?
Maybe not the second one.
Yeah, so this one, y is by itself. So that's already in slope-intercept form. Well, we need to get y by itself. So let's do that here. Let's put it in blue. So if I put this x over there and then divide everything by 2, I would get y is less than or equal to negative 1/2 x plus 2. Okay, I did that. I skipped a few steps, but basically putting x over there, you have x plus 4 over here, or negative x plus 4 over here. Everyone see that negative x plus 4, and then when you divide it by 2, negative 1/2 x, and then 4 divided by 2 is 2. Okay, so I'm going to graph this. The y-intercept is 2, and the slope is negative 1/2. So negative 1, positive 2, down 1 over 2. Down 1 over 2. Okay, so this is what this guy looks like. Now, am I going to shade above or below that? Below, because it's less than, right? And it's equal to, so I get to have a nice solid line. So it includes the line and everything less than the line. Okay, so I'm going to shade below it. Feels great. Now, how do you graph y is less than 3?
Straight.
Yep, so that is a horizontal line, and it's everything less than 3. So, and it's not including 3, so it's going to be a dotted line. Okay. So now I have to see what they share in common. So it looks like that's that. What do you get when you mix green and red? Brownish. So it looks like that brown is the solution. So it's not up here. So if I kept going here, So you don't want to include that part. So usually when you intersect two lines, you have four sections. See the four sections? This big open one, this bottom open one, this smaller acute one, and this right acute one over there. So what they share in common is this bottom obtuse part right here. Okay? So the question asks,
Well, wouldn't they make sure the top one is fine too?
yeah, that is obtuse, but that's not shaded. So it's got to be where both of them are shaded. So that's shaded. So see, there's just red here, and there's just green. There's just green here, but there's green and red here. So this is where they intersect. This is what they have in common, the brownish, because I colored green on top of red, or red on top of green. Okay. The question asks, determine whether 2, 1 and 2, 2 are solutions of the systems of inequalities. Well, 2, 1 is right here, and it looks like that is a solution. 2, 2 is right here. So 2, 2 is not a solution. It's a solution to the y is less than 3, but it's not a solution to y is less than or equal to negative 1/2 x plus 2, because it's not below that blue line. So 2, 1 is, because it's on the line, because it can be less than or equal to that line, and it's less than y equals 3. So 2, 1 is a solution. Well, I mean, it's a solution. Like 2, 2 is still a solution to the red equation, to the y is less than 3, but it's not a solution to the system of linear inequalities, because it has to be true for both linear inequalities, okay? All right, let's try another one. So this is example 2. A, we're going to graph the system of linear inequalities and describe the solution set. Okay, here's the system of linear inequalities. 3x minus 4y is greater than 8. And then another equation, y is greater than or equal to 3/4 x plus 1. Well, that second equation is a nice little gift, right? It already is in slope-intercept form, so how do you graph that? Just walk me through that. So remember, that constant is the slope, is the intercept on the y-axis, and then 3/4, up 3 over 4, up 3 over 4. So this is rise, remember, and this is run. So we're going to rise 3 and run 4. 1, 2, 3 over 4. 1, 2, 3 over 4. Okay, so it looks like it's greater than or equal to, so I get to do a solid line. And it's greater than or equal to, so which part do I shade? Above it, okay? So really, you don't really have to shade it yet, but if it helps, you can, okay? So it's everything above that, up into infinity, okay? Now this one, we need to work that a little bit. So what do? Get the y either on the other side or by itself on this side.
Subtract the 3x.
Okay. So now I've got negative 4y is greater than negative 3x plus 8. Now what? Yep, and what happens when you divide an inequality by something, by a negative number?
You have to switch this.
You have to flip it. Okay, so I divide by negative 4, divide by negative 4. So y is now less than negative 3 divided by negative 4. Negatives cancel, goes 3/4 x. 8 divided by negative 4 is negative 2. So negative or less than 3/4 x minus 2. How do you graph that? Start at negative 2 on the y-axis. Yeah, same slope, up 3 over 4. So it's a parallel line. Is it a solid line or dotted line? Dotted. So, and it's everything less than that. Okay, so what do they have in common? Nothing, no solution, okay? If it was greater than, then this would be your solution set, is this line here, okay? But it's not, it's less than, they have nothing in common, they'll never overlap.
So there is no solution set?
Correct. So the answer is no solution. You might still be asked to graph it, so you can still graph it like that. But the solution is just empty set or no solution. Okay? All right, 2B is graphing on a calculator. You can look, if you want to look at the GeoGebra.com, you can graph. Those are always nice, but no pressure there. Actually, let's do it. Let's just do it because it's fun to watch. I'm going to project it up there, and then then people will be able to see it at home too. Okay, so share screen, GeoGebra. So the first equation, or let's just graph this one. So we got 3x minus 4y is greater than 8. Okay, and let me make sure you guys can see it. Okay, that's right. That looks right. And see how it's dotted on there? Looks good. All right, our next one is going to be y. And this is how you do greater than or equal to. You just put a greater than sign and then an equal sign right next to it. And then it does it automatically. 3/4 x, so 3 divided by 4. Oh, you know what I have to do now is you have to do space, not 2 spaces. So I think the way you have to do is, so you can either do parentheses, 3 divided by 4, or you can just say 3x over 4. X plus 1. Okay? So you can always check your work on GeoGebra.com. It's a nice little website there. Okay? Questions? All right, let's try one more example. And this is just with 3. So this is even easier. It just kind of narrows down your solutions to just one section. Okay, so here's example 3. We've got x is greater than or equal to -4. Then we've got 5x minus 2y is less than or equal to 0. We got x minus 3y is greater than or equal to 6. Okay. First up, how do you graph x is greater than or equal to -4? Yep, and it's solid. So we're going to shade everything over there, but I'm going to wait to shade it. I'm going to convert this. Remember, get rid of that 5x over there. So what ends up happening is you get y is greater than or equal to positive 5/2 x. Yeah, just 5/2 x, right? Because then when you divide by 2, 0 by 2, you don't get anything or whatever. Okay? So how do you graph that? It's at the origin, because there's no intercept, plus 0. It's at the origin. 5/2 up 5 over 2. And it's greater than, this is what this line looks like. We're going to do the greater than and less than shading later. Let's get this y by itself. So you're flipping this as well. So y is less than or equal to positive 1/3 x minus, no, is it minus? Yes, it's minus. Minus 2. Okay, so here's what this looks like, and it's 1/3, so up 1 over 3 looks like this. Okay, so this is shading less than the green, and it's shading less than the blue, or greater than the blue, and it's shading to the right of -4. Can you see which section out of the 1, 2, 3, 4, 5, 6 sections, 7 sections? So this is what I'm seeing, that little note there. So see how this is greater than blue, less than green, and to the right of black.
So greater than is always above the line unless it's 100% vertical.
And then it's easy because now you're just measuring left and right. So greater than in X language is to the right.
Okay, but you
Right.
don't shade the blue line in X language.
Yeah, so that's still, so it's still in terms of Y. So up or down is greater than or shade above, since it's Y, and this is shade to the right of and on top of -4. Okay, so you could shade all that if you wanted to, and then just figure out where they all converge. Right here is where they all converge, okay? But you don't have to shade until you're ready to do that. Okay. Does that feel okay? It's kind of fun because you get the color on your paper. Okay. All right, let's move on to lesson 44. Got a graveyard of all my black pens. I use too much black, and that's what I do.
Not throw them away.
I don't, just in case I'm desperate, and because those aren't totally dead, they're just weak like that. Okay, so let's see here. We're going to 44. I could. I need to branch out. I need to be more colorful. Okay, we're going to rationalize denominators. We did this in Algebra 1. So here's the rule. You can't have an irrational number in the denominator. So do you guys remember what some examples of irrational numbers are? Pi. So you can't have pi in the denominator. What else are irrational numbers?
1/3.
So 1/3 is rational, and it's repeating. If it has a pattern, it's not irrational. But if it goes on forever and there's no pattern like pi, then it's irrational. Anytime you try to take a square root of something that's not square rootable, like the square root of 10 seems like a really innocent number. Nope, it's irrational. Okay? Square root of 16 is rational because you can actually take the square root of 16. But if you have something in a radical that you cannot reduce completely, so to get rid of the radical, then it's irrational. Okay, so here's the rule. You can't have radicals in the denominator. So for example, if I had 3 over the square root of 2, that is bad grammar. Okay, but there's good news because you can do whatever you want to a fraction as long as you do the same thing to the top. So how do you get rid of a square root? You square it. You multiply it by itself. What's the square root of 2 times the square root of 2? 2, right? Square root of 2 times square root of 2. If you did the math, it'd be square root of 4. Square root of 4 is 2. But whenever you multiply a radical by itself, it cancels the radical. Well, this is okay as long as you do the same thing to the top. Okay, this is just one big fat 1, right? You can do that whenever you want. You multiply the same thing on the top as you do the bottom. That's fine. So then you get 3 times radical 2 on top. And then you get 2 on the bottom. This doesn't feel like you're simplifying because the general rule for simplifying, remember, is to write it with less ink and less lead. Well, I have to write more numbers here when I rationalize that. But this is correct grammar. Now I have a nice, cute little 2 in the bottom. All right? You can't have a radical in the denominator. All right, let's try an example. See if you can do this. Example 1a. I want to rationalize or simplify this. 3 over 2 radical 5. How do you simplify or rationalize that? Well, the 2's fine. The 2 can be there, but what can't be there? So how do you get rid of radical 5? Right, multiply both the top and the bottom. You multiply the bottom by radical 5, and then whatever you do the bottom, you have to do the top, right? So then we get 3 radical 5 on top, and then we get 2 times radical 5 times radical 5. What's radical 5 times radical 5? 5. So 2 times 5 is 10. That's it. That's what you have to do. That's correct grammar. Don't go around writing numbers like this or fractions like this. It's embarrassing. You don't want to get caught doing that. Okay, so let's Saxonate it a little bit. Try to complicate things a little bit. Square root of 1/8. Well, can you take the square root of 1/8? No. But you can take the square root of 1. Remember, when you have a division problem inside the radical, you can make a division problem of 2 radicals. So this is square root of 1 over the square root of 8. Well, what's the square root of 1? 1. The square root of 8 we have to deal with. Now, technically, you could simplify that. You could do that right now, because there's a square inside of square root of 8. What is living inside of there that you need to take out? Right, so square root of 4 is 2. So square root of 8 is just 2 radical 2. So then I get 1 over 2 radical 2, but I still have to deal with that radical 2. So how do you get rid of that radical 2?
Just put it on, well, multiply top and bottom by radical 2.
Right. So 1 times radical 2, no problem. Radical 2. 2 times 2 is 4. So that's it for there. But now let's see if we would have done it this way. Let's see if we would have just decided to not reduce that square root of 8 radical. So how do you get rid of radical 8? Somebody besides Drew. How do you get rid of that? How do you get rid of a radical? What? Yep, multiply by radical 8. Nothing wrong with doing it this way. So then you get radical 8 over 8, right? And then you have to deal with that radical 8. So how does that reduce? So that's radical 4 times radical 2. So that's just 2 radical 2 over 8. And then look what you can do now. This 2 and 8 are out in the open. You can reduce that. the 1/4, right? So 1 times radical 2 is radical 2 over 4. You still get the same answer. I think it's easier probably to deal with that first, because then you have less reducing in the end there. Okay. Okay, so we're going to talk about something that's a newer, it's not, I think we did a little bit of this in Algebra 1, but this works great if there's like just a radical or a factor that's a radical. You can get rid of it pretty easily by just multiplying and you're good. But I'm going to give you a different scenario that that system will not work anymore. Okay, what if I had something like this? If I had 5 over radical 3 plus 2. Okay, so if it was just radical 3 down there, I would just have to multiply by radical 3 and I'd be good, right? So if I try this with this situation, what happens? You get 5 radical 3, and then you have to distribute that. And that cancels. The radical 3 times radical 3 is 3, but then you're left with this. So now you're right back where you started. You have to get rid of that radical. So this doesn't work. So I'm going to introduce, not a new word because you would have learned this in Algebra 1, but these are conjugates. So a conjugate of a radical expression or something like this. Conjugate of A plus B is A minus B. Okay, so a conjugate of a sum of two things is just switching that addition to subtraction, or vice versa. So vice versa, conjugate of A minus B is A plus B. Okay, now we're going to use that here. So what's the conjugate of radical 3 plus 2? Right, multiply. Now here's why this works. So if I multiply this by radical 3 minus 2, whatever you do to the bottom, do to the top. So now you're going to have a big mess on top. Let's do that first. You get 5 radical 3 minus 10. And then what happens when you FOIL this out? FOIL it out. You get 3. Because radical 3 times radical 3 is 3, right? And then you get radical 3 times negative 2. That is minus 2 radical 3. Uh-oh, you've got a radical in the denominator, but wait a minute. Because when you do the inside term, what you get positive 2 radical 3. And then 2 times negative 2 is negative 4, okay? Okay, so guys, you're not going to stay awake and you're not going to be off your phones. This you're gonna fail this. Okay? This is difficult. So please pay attention. It's important. So when you FOIL this out, these cancel and you're left with this nice little 3 minus 4. That's the power of the conjugate. Because this is a difference, it's like a difference of 2 squares type of thing. Remember when you have a difference of 2 squares, the middle terms cancel. That's what you want because the middle terms had radicals in them. We don't want radicals in the denominator. So then you get 5 radical 3 minus 10 all over 3 minus 4, which is negative 1. That's nice. But then if it's divided by negative 1, technically the better way to write this is Negative 5 radical 3 plus 10, or 10 minus 5 radical 3. That worked out real nice. Okay, so let's see if you guys can do this. This is example 2a. And I want to rationalize or simplify this expression. 2 over negative 4 plus radical 3. Okay, so this time you can't just multiply by radical 3. You have to multiply by the conjugate. So see if you can do that. I mean, it is possible to do it in your head. If you want to try it in your head, you can. But that's a lot of information to store in there. So see if you can do this. Assuming the video, the recording will not be backwards. That would be not good. Is it recording? It is recording.
That's how they'll see it.
Is it?
You have to go into a setting and change that to the recording has to manually flip it so that it flips back to them.
I'm going to try to log in. Oh, just did that instead. Okay. Oh, I think we're good.
Are we?
Yeah. This is more for just. And this is more for just. I think it. What's that? What's that? Yeah. Yes. Stop it. Okay, now if I leave this, it's going to. Okay, are we still recording? We're good. Okay, so I'm going to jump in here. I'm multiplying by the conjugate. You don't have to complicate things. You could reverse that, I guess, and say radical 3 minus 4. And then the conjugate would be radical 3 plus 4. It doesn't matter. You'll still get the same answer. So I'm going to multiply by negative 4 minus radical 3. All I'm doing is changing that addition to a subtraction problem. If this was already a subtraction problem, I would have changed it to an addition problem. Whatever you do to the bottom, do to the top. Okay, let's do the top first. 2 times negative 4 is negative 8. 2 times negative radical 3 is negative 2 radical 3. All over. FOIL this out. 16. And then I don't even have to do these guys because I know that those are going to cancel. So I can just skip right to the F and the L. I don't have to even worry about the O and the I of the FOIL part. Okay, so then I get minus radical. What's radical 3 times radical 3? 3. So minus 3. So then I end up with negative 8 minus 2 radical 3 all over 13. And if you did it the other way, you would have gotten the same answer. If you would have said radical 3 minus 4, then you would have ended up with a negative 13, but then you would have had a positive 8 plus 2 radical 3 up on top. That's still the same answer. Okay? So your solutions manual might look a little different, but just if that's the case, just negate everything and see what happens, because you might probably have the same answer. Okay? You can negate everything as long as you do it to both the top and the bottom. You just multiply by negative 1. Okay. 2 more examples and we're done. See if you can do this one. 3 over radical 5 plus radical 2. That's okay. There's nothing wrong with that. You can still multiply by the conjugate. Do it. So you're not going to FOIL it out. You're going to fool it out. You don't have to even do the outside and inside products. You could probably do this one in your head. All right, girls. What do I multiply by? Well, not the bottom by the top. Right.
Well, yeah.
Minus radical 2.
Minus that.
Good.
Same thing to the top.
Nice.
So then FOIL that out.
So you get 3 radical 5 minus 3 radical 2. Okay, so can you do that in your head?
Well, it's 5 minus.
5 minus 2. Yep, so you just get 3. Now look, you can reduce that. You can divide 3 out of both of those, and you get radical 5 minus radical 2. That was a nice answer. So always look to see if you can reduce. Remember, in order to reduce, you have to be able to reduce everything. So you can't just cross out those 3's, right? So so algebra 1. Don't do that. Okay? If you're dividing by 3, you have to reduce everything by 3. Those cancel. Okay, one more, and then we'll be done. Do a clean slate here. Kind of clean. I'll keep this on the bottom so you can reference it. So conjugates will get you out of a bunch of jams. They're a nice tool. Okay, so the only difference with this one is you already have a binomial on top. So you already have something confusing already on top. So see if you can rationalize this. Okay, so do the same thing, same steps, but the top is going to be a little bit more difficult because instead of just distributing like this 2 to both things, you have to FOIL the top as well. And you actually do have to do the O and the I of that FOIL because those middle terms won't cancel. The middle terms on the bottom will, if you multiply by the conjugate, but the ones on top won't. Okay, so take a few minutes. If you're doing this, take just about 60 seconds, and then I'll catch up with you. Hey, what's my conjugate? Nice. Whatever you do the bottom, do the top. So this time I'm going to do the bottom first because that's the easier one. Can you do that in your head? It's a little bit tougher to do in your head because squaring that's a little weird, I guess. 9 times 3, which is 27. You see how I got 27? Goes 3 radical 3 times 3 radical 3. 3 times 3 is 9. Radical 3 times radical 3 is 3. So that's 27. So it's 4 minus 27. You guys see that? Okay, let's FOIL the top. 8 plus 12 radical 3 plus 2 radical 3. Do you see where I'm getting these? Plus 3 radical 9. So 3 times 3 is 9, right? Because that's 3 radical 3 radical 3. So that's 3 times 3, which is 9. Okay, so I can combine like terms. Combine the like radicals and combine the constants. So you get 17 plus 14 radical 3 all over 4 minus 27 is negative 23. Nice. So the answers aren't quite as satisfying. They're kind of bulky, whatever. It's nice when you get a nice little answer, but that's the right answer. But what makes it right, the most important thing is there's no radicals down here. They're all up there. And we've simplified as much as we can. The top, you combine like radicals and the constants. So that's it. That's the least amount of ink you're allowed to write that answer in. Okay? All right. Does this feel doable? All right. Good job.
Flack!